Everyone wants a bit of metal, whether it's to make skyscrapers, cars, to make a pan to make our lovely eggs in the morning, and of course to make rings for that big question. But where do they come from? Ever seen rocks like these before? These are examples of metal ores. This one here is called bauxite. It contains aluminium oxide. This one here is called hematite. It contains iron oxide. And this one here is an iron pyrite, which is a type of iron ore, and it contains iron sulfide. An ore is a rock or mineral from which a metal can be extracted. There are some metals that don't usually exist in the form of ores, and this is because they're very unreactive and they rarely combine with other elements. Can you guess which these are? Yeah, you got it. Gold, silver, copper and platinum. As these metals are unreactive, they keep their shiny appearance for a long time, which is why they make brilliant lifelong presents. Metals in ores, however, are very reactive and hence bond to other elements. Metallurgists have come up with different ways of extracting metals depending on how reactive they are. The method used to extract a particular metal depends on how reactive that metal is. The more reactive the metal, the more expensive the extraction process. There are usually 4 steps in the extraction process. The first is mining. This is a process of digging up rock, sometimes by building deep shafts and tunnels into the Earth's crust. The next stage is to concentrate or separate the ore from impurities such as soil and other rock. Hematite may be up to 80% pure iron oxide, but copper ores rarely contain more than 1 or 2% of the pure copper compounds. You can see why it's important to find sources of metals that make it economically sensible to extract the metals. It's no use spending a lot of money concentrating an ore if the metal you produce isn't that valuable. Prices of metals go up and down depending on the demand. Stage 3 is reducing the ore. Most ores are compounds, well actually metal oxides. So therefore we can remove the oxygen to extract the metal from its ores. This is called reduction. There are 2 main ways of reducing a metal from its ores, depending on where the metal is positioned in the reactivity series. Any element in the series can displace an element that is positioned lower in the series. Carbon is included in the reactivity series even though it isn't a metal. And this is because metals below carbon in the series can be extracted using carbon itself. You can see that metals zinc, iron, lead and copper are below carbon, and this means they can be extracted cheaply by the reduction of their ores with carbon. Because the metal has lost its oxygen, we can say it has been reduced. Because the carbon has gained oxygen, we can say that it has been oxidised. So we can describe these processes in a general word equation. Let's have a look. Metal oxide plus carbon gives metal plus carbon dioxide. The metal oxide has been reduced because it's lost its oxygen, and the carbon has been oxidised because it's gained oxygen. Let's take a look at an example. Here is the word equation for the reduction of lead oxide. The lead has been reduced because it has lost its oxygen. The carbon, again, has been oxidised because it has gained oxygen. So how can the more reactive metals such as aluminium and magnesium, which are found above carbon in the reactivity series, be extracted from their ores? These metals are extracted from their ores by a process called electrolysis. Electro meaning electricity, lysis meaning breaking down. This process uses electricity to split metals from oxygen. So the metal is reduced. But this time, instead of using carbon, we use an electric current. Because the extraction needs large amounts of energy, this makes the electrolysis process very expensive.